Hello, I'm James Sylvester of JPS Reliability, and what we're going to be sharing with you today, which is a hope for the start of a long series of free training videos. And what we're going to concentrate on is vibration analysis. This leads on from the success of our Book of Gold case studies, and this whole series we're going to class as the Analyst training, and this is case study 1. The background to this one is a boiler feed pump with insulated bearing with EDM damage. As we often say, condition monitoring alone does not improve reliability. But you can improve reliability, you can enhance your system reliability, improve machine uptime. Once you know and you determine the failure modes, you apply the correct condition monitoring technology and you can prevent it from failing, and that will drive your tasks. But the whole way of improving reliability is that once you know there's a failure and it's a repeat failure, you need to work out why it's failing and put in a task, if it's cost effective, to mitigate that failure, and then that will be improving reliability. So who are JPS Reliability? Well, myself and the other director, James Pearce, we have over 40 years combination of experience in the condition monitoring, maintenance, reliability practices. We work with many of the blue chip companies all over the world: UK, Europe, USA, Canada, Australia. Our experience is in every technique because each technique lends itself to a particular failure mode, and if you know all the techniques, you can combine them together and have a really great program. We all have the various ISO qualifications. Our other team members, they have around 5 years experience, and we're training them in a JPS way of the correct work ethics and doing it right. We're registered with many of the engineering colleges. We're SSIP, Accumulus Safe Contractor, Safe PPQ certified. And what we feel is our biggest achievement is our publications to help people learn in condition monitoring, especially vibration analysis. We have our first publication, Enhancing System Reliability through Vibration Technology. This one here is my 20-year notes. So for me to understand things, I worked on the tools straight from school. I used to write things down in my particular way I could understand, and it helped me learn. And basically I had all these black books and I turned it into this book. So this is vibration analysis and reliability in a common sense, practical way, helping technicians. That then led on to our JPS Reliability Book of Gold, which is over 100 case studies of stripped down and failures, and that book popularity has led on to this presentation. So JPS have mentoring, training and services. So we have a dedicated team. We're all practical from the tools working up, so we understand how things work and how things fail. And we pride ourselves on helping people and doing it right way. This is a map of the reach of our book, so you can see we're covering nearly the whole world, and yes, we're quite proud. So back to the case study of our analyst training. This one here, the history of this is it's an asset we've been monitoring for a while under a routine service contract. It's a boiler feed pump. As you see on most sort of power stations, you either have 2 or 3 boiler feed pumps feeding the water boiler. They're not usually on the online system as the turbines are. They're sort of the auxiliary fixed plant. So we monitor this. We've monitored it for a while, and we had a defect, and we used an additional tool of a shaft voltage pen to confirm what the vibration was saying. They only have annual shuts, so we ran the risk so much that at the next shut we said this is too high risk, the bearer needs to be pulled, and this is a case study to show you the vibration data and how we did it. So next we're going to jump into the vibration software, and I'm going to show you a bit of an analysis and how we detected what the defect was. So here we are on the vibration analysis software. We can see our folder, the Book of Gold 2, and this is our case study training analysis number 1. What we collect mainly is vibration velocity, acceleration low end and acceleration high end, and peak view. So here we have our velocity, our low acceleration, here we have our high frequency acceleration, and here we have our peak view data. And what we did on this one, we've been trending this one for a while. You can see we started to have activity here, some electrical activity, around then. Let's change that to hertz. There we go. See, so you can see even back months, well, years ago, we were getting around 2 times the drive frequency pulse from the drive. So we've always been having some electrical activity. We knew there was something occurring, but gradually over time it increased, got higher and higher. Impact has started to come there. And then just before discussion of the planned outage, it went up quite high. So now the risk is really high. We cannot push this asset any further. What's good about this software is, obviously, the first thing you've got to do is make sure you've actually got your one order correct, because without your correct running speed, all your bearing defects will not be correct. So we go through the software, we toggle, and then we find the first peak, which we know is around one order, 48 hertz. We can toggle straight into RPM, 2,932 RPM. Make sure you get the correct RPM set across the whole asset. And for analysis on this particular one here, where it peaked at its worst, if we click on the plot here and we toggle for a harmonical family, we actually find straight away the software picks up order at 3.085. Then we can just quickly overlay our fault frequencies and bang, there you go, outer race frequency. But what's different about this, which shows you it's EDM, is you usually get this high amount of activity around, sometimes around the drive frequency, and it's sidebanded by outer race, whereas a normal outer race defect frequency, you usually get a higher one order BPFO, 2, and it sort of comes down like it's ringing. This is the bearing basically screaming because of the drive. Again, we can look at the time waveform. You can see here a peak to peak of what, 10, 20, 32, 33 Gs, and you can see its pulse in there. Well, we can zoom into the software and we can put a peak on the top, and then we can actually go through, toggle and overlay our fault frequencies and see that this big pulse is all at the outer race. Another great thing in this software is if we pull back, it's called autocorrelation. So within this time waveform here, if we clear the plot so you can see it again, we can actually autocorrelate. Now what autocorrelate does is it works perfectly only when you have the speed set correctly. We can autocorrelate it and bring out another waveform. Now this shows us what within that data is reoccurring at a period frequency. You can see it looks a bit like an optical illusion. There's quite a few things going on there, but if we zoom into a small portion of it, we put our cursor on the top, jump up to top, again toggle through the fault frequencies, you can see that these pulses are bang on outer race. So outer race is screaming, but it's riding upon a really high frequency. Now, what is that frequency? Well, if we set our cursor to a reference cursor, toggle to sidebands, then we can actually bring out some sidebands to have a look. So if we zoom in to one of the pulses, bring our sidebands out to the top, there we have it perfectly. So this outer race defect frequency, which is not a normal outer race defect frequency, is occurring on the frequency of 1599 hertz. Now, when we go back to the spectrum derived from the waveform, look at this mound is around 1500 hertz. So that's our electrical drive noise, which is killing our bearing, giving us EDM, and hence why you get the hump sidebanded by outer race. We can jump into the peak view data, and you can see here the change straight from when the bearing was with defect and no defect. But the big giveaway, as I say with these bearings, is your high frequency. You can see it there. And what's pretty cool, again, another function of the software, is we can actually overlay before and after. So when you want to show someone, look, this is the bearing screaming, you know, 20, 30, 40 Gs, and this is the bearing after. Okay, so that's a quick little squiz at the data, how we analyze it, how we came up with that. It was actually EDM to the outer race. Okay, what we're going to do now is we're going to jump in to look at some of the bearing photos. So this is the bearing when we received after overhaul. You'll see it's a 6316. You'll see the long code at the end to indicate it's ISO coat bearing, and you can actually see the grey coat on the bearing. So this was fitted to the non-drive end of the motor, and it is failed due to EDM damage. So the bearing technically was still working, so it wasn't a functional failure. We pulled it before the bearing was a functional failure. And what we have found with EDM problems is they're not so uncommon now. They're more common because the more drives are people are installing to save energy. But you're not looking at the whole system, the cabling and the earthing, that it needs correct earthing for this high frequency current. And we've had two of the same motors on the platform off a drive, and they will behave differently, even down to when they're overhauled and they're put together and the spigots are put in. If a spigot's put in with nice clean metal to metal contact, it's a better path. If it's got Hylamar insulation, silicone, it dampens it. They do not behave the same. They're very, very different. This is the inner race and it's the outer race, so you can see where we got the load zone of the bearing, which has got the higher banding of the EDM, and the opposite end where obviously the bearings come around and it's not touching it or loading the bearing. It's not making that contact for the current to discharge through it. So as usual, you see it in the deeper in the load zone. On the inner raceway, you can see the dullness of the track, which is due to common male voltage, and you can actually see it's actually slightly offset. So whether something was in the magnetic field, coupling not perfect, but you can see the bearing was slightly offset. We got a common male voltage, but it is actually discharging through the outer race and trying to get down to earth back to the transformer. These are the bearings. You can see little bands, the bands, well, those grey bands is as it's going around and it's the surface contact and it's discharging. So you can see it's a classic EDM failure. The question now is how to prevent it. How do you stop this happening again? You could fit grounding brushes, grounding rings, special grease which carries the current through to make it go to earth easier. But the correct way of fixing it is fix your earthing. But unfortunately, money comes into that. So there's a cost payoff for a reliability engineer of what fix for how long it'll last against how much it's going to cost. So that's where the reliability engineer needs to start looking at the costs. I've got the bearing here, so I'm just going to quickly show you the bearing so you can actually see the component itself. Oh yeah, so this is the bearing in question. You can see the powder coating there on the bearing, all grey. You can see it's a brass cage bearing, so it's a, it's a decent sized bearing. And what we can do is, if we look on the outer race here, you can see the EDM path all the way around there. And when you actually go to the opposite of it, the non-loaded side, you will see the path gets thinner. So that's classic with a bearing, obviously with it up like so. Gravity is pushing down, it's going around, and it's a tighter contact. The balls are going through the loop, and yeah, that's where the EDM passes through. Now actually on the balls themselves, it's sort of hard to see, but if you look on there, you can sort of capture dull stripes. So the dull stripes is as the ball's spinning, that's a contact path, and that is where the EDM is starting to build up a capacitor, breaks the grease down and arcs through and gets back to the transformer. This is the inner raceway, so you can see it's offset. The actually inner part of the inner raceway is perfect, no fretting at all, and you can see that there it's slightly offset. So as I say, we're going to try and do some more of these, but I say this is the bearing in question. So now we've seen the vibration data, we've seen the bearing images, we've actually physically seen the bearing. What's the failure mode? Well, you can say the failure mode is ISO 15243-543. Current, leakage, erosion due to the EDM damage. Now, is that the failure mode? Is that the root cause? Or is the root cause all the way back to the electrical engineer who was designing the system? Didn't take into account or understand the effects of the high switching current in the drive? Now is that the root cause failure at the design stage? Not just the drive because the drive caused it. The drive caused it because of the lack of high frequency earthing. So there's a debate on the failure mode or the root cause, but as you say, technically it's current leakage erosion but it's due to the lack of high frequency earthing, which comes back to the design stage that is not taken in consideration in the design or the retrofit. Thank you. Well, we do hope you like this new layout for these free training videos, and we hope there are some useful to everyone out there. Please do comment on the YouTube video if you think we should do it in a different direction, and say we're going to change the format each time to try and find the optimal format for everyone to appreciate. And if you need any help, contact us. Obviously, we got our book of gold, which is bridging the gap in the ISO body of knowledge and the real life practical training. So it's those 180 vibration case studies, and also in the back we've got 18 thermal imaging failure defects which we've discovered over the years. So we thought we'd put that in the back of the book because thermal and VA can work together quite well. I say, if you want a book, get a hold of us, go on our website. We've got a list of the suppliers all over the world, from Australia, Canada, America, UK, Europe. And if you need any help in database creation, setup, review, training, as we say, we specialize in mentoring and helping get your team up to speed so they get the best out of the program. Yeah, just get a hold of us, and take care and have a good day.